1.8 absolute value. In this section, we are going to learn how to define and use the absolute value. Solve the absolute value, one absolute value equation. Solve the equation on both sides has two absolute value. Solve the inequality that associate with the absolute value. So absolute value of the real number x, we use a true bar to cover the x term. So the idea is when I have the absolute value, for example, I have -4 inside of the absolute value. When I remove the bar, it will turn to a +4. So when I have a +4 inside of the absolute value here, when I remove the bar, it turns to the 4. So that means you will have two possibilities. There's two conditions inside of the two bar of the absolute value equation. One is a positive, the other one is a negative. And when the bar got removed, both of them they turn to a positive number. So we do a practice of the absolute value. This one, we have 7 with absolute value, so the result will be 7. B is 3. C here has 7. However, the outside, this negative sign is outside of the absolute value, so it's here. It didn't go away. D, you have the x minus 2 is inside of the true bar. So you will have two solutions. One is x minus 2. Another one would be negative x minus 2. So it will turn to the negative x plus 2. So when you solve for the absolute value, or the number carry the absolute value sign, when the bar got removed, it will turn to a positive always. And when you have the variables inside of the absolute value, it turns out you will have the two possibilities of the solution. Now we solve for the equation of the absolute value. So when you have the equation x with absolute value equal k, is equivalent to the x equal k or x equal negative k. For example, this equation, the first step is we isolate the absolute value by itself on one side. So the 3 move to the right, you will have the 7. And the left hand side, you only have the single absolute value. From here, we separate this equation into two parts. One part would be 3x minus 5 equals 7. Another part would be 3x minus 5 equals negative 7. So from here, we solve for x. This is 12. 3x, this is negative 2. So x equals 4 or x equals negative 2/3. So you will have two solutions of this equation. Now, these two solutions that represent, there's a 2 point on the number line. So when x equals negative 2/3 or x equals 4, the absolute value equation will equal 0. If the equation, both sides of the equation carry the absolute value, so absolute value A equal absolute value B, we can separate this equation into the A equal B or A equal negative B. So we practice this one. The first step is we let the 2x equal x minus 3 or 2x equal negative x minus 3. Keep in mind, once you separate the equation into two parts, there's no longer has the absolute value sign. So from here, we solve for x. Bring this x to left hand side, we'll get an x. So x equal negative 3. So this is one solution. Another solution is x equal 1. The next one, we are going to solve for the inequality of the form of the absolute value. So when you have the x with absolute value is less or less equal, less or less equal, both of the symbol, they go to the same direction. The difference is only has, this one doesn't have the equal sign, but not this one. But they use the same condition. If your k is greater than 0, which means your x, alright, let's use another way. Recognize the direction of your inequality sign. When you have less or less equal, you always rewrite this inequality form into the x is less than k greater than negative k. Always. Okay? So when you have the x is less equal than k and greater equal than negative k. When you have the less or less equal condition, you rewrite your inequality absolute value equation into these two different type of form based on the direction, the symbol, whether you have the equal sign or not. So we do a practice of this one. X minus 2 less than 7. So this is a less condition, right? So I'm going to use rewrite it into the compound inequality. So we'll have the x minus 2 less than 7 greater than negative 7. Now from here we solve for x. X will be between 9 and negative 5. So when I draw the number line, since negative 5 and 9 there's no equal sign, so it's open. This is 9, this is negative 5. So all the number between these 2 points that will satisfy the solution set of the x. If you go with the interval notation, this will be the open parenthesis, and you put a negative 5 on the left hand side and the 9 to the right hand side. Now we do the other way around. When you have the absolute value, inequality has a greater or greater equal sign. When you have the greater or greater equal sign, we rewrite then into the OR condition, which means you'll rewrite it into the two individual inequality equation. So when x with absolute value is greater than k, we rewrite it into the x is greater than k, or x is less than negative k. When you have x with absolute value greater or equal than k, you rewrite it into the x greater or equal than k, or x less equal than negative k. So when your inequality sign is less or less equal, you rewrite it into the compound inequality form. Compound inequality. So you'll have the x between, crown in the between. When you have greater or greater equal condition, you rewrite it into the two different individual or single inequality form, and you put the or in the between. We call this is disjoint, and the previous one is the joint condition. Okay, so we do the practice of this one. This one has greater or equal than absolute value plus 7 greater or equal than 12. So the first step is we isolate the absolute value on one side. So you'll have 2x plus 3 over 2 with absolute value greater or equal than 5. Now from here, we start to rewrite it because this is greater or equal sign. So we separate this equation, this inequality equation into two parts. So one part will be 2x plus 3 over 2. Sorry, when we rewrite, there's no longer with absolute value sign. Let me erase it. Okay. So we start to rewrite. We rewrite it into the 2x plus 3 over 2 greater equal than 5, or 2x plus 3 over 2 less equal than -5. And from here we solve for x. I multiply by 2 on both sides. So here cross out, you get a 2x plus 3 greater equal than 10. So 2x greater equal than 7, then x is greater equal than 7 over 2. And now the solution is multiplied by 2, multiplied by 2. So you have the 2x plus 3 less equal than -10. So 2x less equal than -13, x less equal than -13 over 2. So if I draw the number line, label these 2 points, 7 over 5 is about 3.5. And this one has an equal sign, so it's a closed up. So 7 over 2. Or less equal than -13 over 2, which is -6.5. So if I sketch the line based on the inequality sign direction, that means greater than 7 over 2 or less than -13 over 2. This is -infinity. Here is a past infinity. So the shade region or the interval will cover these two shade regions, right? So when you represent the interval notation, you put a -infinity, comma, -13 over 2. And this interval would be 7 over 2, comma, in infinity. You put a union, this is a u. Okay. Put a union in the between, and that would be the solution of this question. Now you can move on to work on with a sign.